Let me start to first present the important guy here today, Dr. Johan Kristiansson at RISE in Sweden, a research institute of Sweden. He has been developing this Colony meta-OS since 2016, I think you have told me. It's quite interesting that we found this meta-OS actually in the city of Luleå. I'm located in Luleå and Johan is located in Luleå. It's interesting since a lot of this work has been connected to various companies where Johan has been working, Ericsson among others, and now he is with RISE and using this meta-OS in a number of research projects. But I think that we give the floor to Johan, and please present the meta-OS, and you will spend about half an hour, or maybe a little bit more, and then we have plenty of time for a dialogue on what the meta-OS actually can do and be used for. So, Johan, the floor is yours. But we don't hear you.
I'm mute. Do you hear me now? Can you hear me now?
Now we hear you. So,
and you see my screen. You also see my screen.
Yes, we do.
All right. Okay. Yes, my name is Johan Kristiansson, and I'm thank you for inviting me talking about this. It's quite exciting, actually. So as Jerker said, I'm working at RISE, and I have also been working at Ericsson and different other companies around, mainly in the Luleå area in northern Sweden. So yes, I will talk about this project, and yeah, I have a lot of slides, but I will rush through the slides because I really would like to also make some live demonstration showcasing this technology that I have been working on. So this is an open source project, and it has existed for maybe three years, but I've been working with these ideas even longer, as Jerker also told you. And right now, one of the use cases of this is to make it easier to use supercomputers around Europe. So this work is also funded by the Euro-HPC joint undertaking. To make it easier to use supercomputers. So I will talk a little bit more about that as well. I will just mention some of the challenges. If you look at cloud computing today, it's very useful using cloud computing. If you ever used Amazon, it's extremely useful. But the limitation is that you need a stable internet connection. And that can be problematic, especially for industrial use cases, like the mines, the underground mining, the mining industry that I've been working in. And they also have this other problem with vendor locking and security. The problem is that in some cases you cannot use a public cloud, and setting up an on-prem solution can be very expensive and difficult. And today we are talking a lot about hyper-distributed application that can run across platforms. For example, on IoT, Edge, Cloud, and even HPC. So that is, in generally speaking, if you have a distributed system, and if you have many platforms, there are many moving parts, and that makes it very difficult to manage this kind of application. So you need to oversee operation across all this computing environment. So the question is, does all this problem justify that we add another layer on top of everything, a meta operating system? And that is what I'm trying to argue for today at this presentation. And there is also a lot of talk about the new application that is coming and the need for low latency application, and then we need edge computing. And Yeah, a little bit. The problem with this is that there are so many different kinds of edge. It can be even everything from a smartphone, even an IoT, to a regional data center. And edge compute, what edge computing is not is obviously not people, and it's not cloud. But going back, if I go back like 10 years ago, I read this book, and it's I was working at Ericsson. The book has mixed reviews. Some people don't like it. I like it a lot. It significantly influenced my view on how internet is supposed to work. So it talks about the shift where computing is not ubiquitous, but it's integrating into the very fabric of our environment. And this is commonly known as pervasive computing. And the book, it doesn't really talk about edge computing or cloud. It's rather talk about nodes. And there are a trillion, it's called a trillion node network because everything will be connected into this pervasive cloud environment. So I read this, I think it's from 2012, but I was working at Ericsson, and since then I have been working with these ideas. So what would be the property of a pervasive cloud be? Well, it would be user-centric. You would allow users should own their own data and control their own services. So it has to be decentralized with no single point of control. And it's kind of ubiquitous, so it's available anywhere, and you would be able to universally access your server, even if they're running on edge, on devices or edge or cloud. And it has to be scalable, secure. And one of this book that I mentioned talks a lot about resilience, so you can make application working become more stable and handling failure more efficiently. So really what I wanted to build was what I'm working on now is trying to create a decentralized meta operating system. And really the key thing here is to provide a coherent unified control layer to control everything and trying also to embrace different platforms. It's not about replacing stuff, it's about integrating, combining different platforms into a unified platform. And by doing so, it would be possible to create a truly seamless edge to cloud continuum where everything can be flow and migrate seamlessly across platforms and infrastructure. So ColonyOS is a decentralized meta operating system, and it's focused mainly on providing this unified and coherent control layer that can integrate with other platforms. And it has a lot of different features that I will talk about. I will trying to explain how this works. But I would like to highlight that security is really where I started. When I started working on this, I was working with blockchains at Ericsson, so I realized that it's not really possible to add security later on. It has to be there from the very beginning. So that's really the core foundation of this framework, the security. So there is also other meta operating system. I think there are 6 different meta operating systems, and there's quite a lot of investment in this. I think if I have to say highlight some differences between these, I would say that ColonyOS is mainly focusing on this control layer and integration. It's not trying to provide a full stack solution or providing some deep network integration. So it doesn't try to integrate with Kubernetes. So it's just focusing on this control layer. So I think it would actually be possible to integrate ColonyOS with some of the other meta operating systems to provide a more efficient and complete solution. And so here is the idea. We're going to, in computer science, they say we can always solve any problem by adding another level of indirection, assuming that there are not too many level of indirections already. So that's the question. Will this additional meta operating system layer, just add more complexity? But I would argue that it would be really nice to have to bridge and the bigger gap between all this and combine all this underlying platform. So a developer, he would use this meta operating system, and you would be able to run workflows and services on top of this. So the basic building block of ColonyOS is extremely simple. The core component is something called an executor, and this is a software basically that integrates with other platforms. So then these platforms can be virtually anything, but I've been mainly focusing on container-based platforms like Kubernetes and HPC, Slurm, and so on. But as I will talk more of later in the presentation, it can also, we are aiming to integrate this with Arrowhead. The problem here, I should mention this before I go, that I've been developing 3 different types of executors called Kube executor, Docker executor, HPC executor. And these are a family of containers called container executors. And the interesting part with these container executors is that they are compatible. So you can take one load and run the identical workload on Kubernetes, and then you can take the same load and run it on an HPC system. And so there are also SDKs in different languages, so you can easily kind of implement your own executors. So I mentioned this basic building block. The problem with this that has to be solved is how do you connect an executor to an application? And there are firewalls on the internet. So how do you connect through the firewalls? And second problem, how do you design this API? How should it look like? And the other problem is how do you coordinate the execution? So you don't want to have the same computation to run on 2 or 3 executors at the same time. You want to run it maybe only once on one executor. And how do you handle resilience if some of this executor crashes? And I mentioned security. How do you do that? And another thing is data. How do you synchronize data across all these platforms? And this is extremely important working with cloud and HPC, for example. You need to be able to shuffle and synchronize data. So the solution to this is to introduce a broker because then we will be able to coordinate, have more control of the coordinating the execution. And that also solves the second problem with firewalls, because then we can have an executor can have a just connect to the broker through firewalls. And that will work anywhere on the internet using standard HTTP. But another thing that I'm working on right now is to use a peer-to-peer networking to do that. And so then that's another option. And I'm very fond of functional programming. So this API that I'm going to introduce, it's based on functional programming. And there is a paradigm right now that is quite popular. It's called function as a service. So this would be very similar. And security, there is not possible to have a parameter security. But there is a security model called zero trust security that hasn't existed for some time. That's actually solved this problem. And I will not spend so much time on this, but I would like just to highlight this data problem. A large part of ColonyOS is a meta file system that will enable synchronization of data in the continuum. And this is the network stack that I'm working on. It's coming from blockchain. It's quite interesting. You can just look it up if you are interested in learning more about it. So this is the architecture. We are adding a broker, and that would be a Colony server. And we will application. They will submit a description of function they want to execute, and this will be wrapped into a process and assigned to an executor. And the executor will connect to the colony server to get assignments. So it's basically a broker architecture. And this is how the function specification look like. It can be a JSON or a YAML file. And it consists of 3 parts. The brokering part that describes the requirement of this computation. And the second one describes a function that we want to execute. And the third one is kind of constraints on the execution. And this is where the last part is very important for implementing resilience. And this is all information that is required this can be converted to a Slurm script. It could be converted to a YAML, Kubernetes YAML file. So it's a very generic common denominator format that describes how to execute a function in a very generic way. So if one of the executor is it crashes, then the Colony service it works as a ledger, so it keeps track of all the processes and the status of these processes. And then you can set this kind of execution constraint that I mentioned. So then it becomes possible to reassign an executor, a process to another executor. And this very simple mechanism is extremely powerful. And another problem here that I've been working a lot with is having if you have a broker, that would be a single point of failure, and we cannot have an architecture with a single point of failure. So ColonyOS is using something called RAFT, which is a distributed consensus algorithm. It can be used for leader election, for example, and coordination. So it's used to implement. Using that, it becomes possible to have a cluster of Colony servers that becomes a Colony node. And these nodes, they can be connected into a global peer-to-peer network. And this enable new kind of enable creation of federations, for example. This is something we are working on right now, and I think the main kind of reason is to enable Colony nodes to be deployed behind firewalls, so addressing this universal access problem. And this is also an exciting thing you can do. Imagine if you have a decentralized Kubernetes platform. Basically, you can just having a container platform where different component can reside on different platforms. That's another thing that this would enable. So this is how it works. We would have a meta operating system, an API that mimics a real operating system. We have process management, logs and file management, etc. And this will be provided by a Colony node. So the executor, they register, and then they will to the broker, to the Colony node. Now they will kind of state their capabilities. Then I use their own application with some MITIS function specifications, which will then be wrapped into a process and assigned to an executor, which will interpret the function specification, do something interesting, and then close this process. But you can also use this meta file system to access data and produce new data. And the Colony service monitoring all this execution history. So this Colony file system is as I said, it's a important part of this framework. It contains meta information about data. And this meta file system can be connected to various storage systems. And it can also use other technologies like IPFS, interplanetary file system. If you wanna, so the interesting part here is that it's also possible to reference files in the meta file system when submitting this function specification. So this JSON description that you see here, it describes a process, but it also describes how to get the data to an executor, how to synchronize the data to an executor. So coming back to this colony, why it's called colony? A colony is basically a loosely connection of executors, and they are several of these executors. They form a group or a unit, a unified compute unit, and that's called a colony. And one of the main mechanisms to implement it is public encryption and zero trust security. So but it also has some interesting property. If one of these executor crashes, or then this description function will not be executed. It will just be stored in the colony's node, and then they will be assigned to another executor. So you get a very resilient system having this architecture. And so I will. This is an interesting topic, but I think I will run out of time, so I will skip all this detail with how this. But I can just say that the crypto protocol that is used in Colony is reusing the crypto from Ethereum and Bitcoin. So that's the where the crypto but it's not using a blockchain. It's just using the crypto. And I will skip this with zero trust, and then I will talk about the use cases instead. So one of the use cases I've been working on is Rock Sigma, and it's a company working with seismicity in underground mines, and what they're working on is creating a tomography of rocks, and so what I've been working on is helping this company to develop a compute engine that can process seismicity, and it can be a huge amount of seismogram waveforms coming into the system, and this seismogram will be processed, and then they will be visualized. So that's what it does, and this can be implemented in this kind of way. We have data coming in from LKB, and then that goes into the BMIS compute engine, and the BMIS compute engine, it will generate function specifications, and this will be executed by a huge amount of BMIS executors. The interesting part, what you can do with this architecture is because it's very resilient. If you want to update an executor, you can just kill it and then replace it with another one, which is kind of nice. But you can also, it's very easy to scale the system. You can just, if you don't have so many low level of seismicity, you can just kill executors. And if you want to scale out, it's very easy. You can just add more executor, maybe from Amazon, Azure, or GCP. And another thing is a very similar use case I'm working with is Digital Art Sweden. RISE is working on we're collecting a lot of satellite data, and we want to this data is stored in our data center, but we don't have any compute. We don't have any GPUs. So the idea would be to use colonies to dynamically add compute capacity to analyze these satellite images. And well, I'm hoping to. We'll actually make a demo of this that I'm working on it's just a demo. I'm going to present this as a Euro HPC Summit next week, so you get a. But the idea is to be able to analyze satellite images by just dragging them to a web server, and then they will upload it to a backend, and this data images will be stored in ColonyOS, and then the function will be submitted to a Colony node, and then that will be assigned to an executor that will analyze this image, and then upload the result to ColonyOS, and then getting this analyzed picture back to the user. And I will demonstrate that in just a few minutes how that could be used. And another tool that I've been working with is called Pollinator, and the motivation for this is that HPC system can be quite difficult to use. And this tool will eliminate entirely the need to learn Slurm Kubernetes. You will have this very nice tool that can work on your local computer, and then you can just run stuff on a supercomputer. And that particular workload can seamlessly run on a cloud platform as well, or even your own laptop. So you basically have this continuum, and you can seamlessly execute tasks. And and then we are working on this. We are starting to think about how we can actually the Arrowhead framework, how that can use ColonyOS to implement Arrowhead components that can leverage cloud computing and edge computing in new ways. So, Jerker, how much time do I have left? I can't hear you.
Yeah, we still have half an hour to go. So if you want to use 5-7 minutes for the demo, please go ahead.
All right. That's the exciting part. So this is a user interface, and we can see, we can just look at the executor we have now. We have a Kubernetes cluster running in our RISE data center. We have the Lumi supercomputer in Finland, and unfortunately it's not healthy today, so we cannot use it. And we have the Leonardo Leonardo supercomputer in Italy. And I also have an edge server in my home. It's basically under my desktop, under my desk. And these are located in Italy and Finland and Sweden, as I said. And the Leonardo, it has a huge amount of GPUs. This is quite impressive. So it has almost 14,800 card, which is kind of attractive if you're working with machine learning, to be able to use this system. And here I can see processes that is waiting and nothing is running, and this is stuff that I've been running before. And I can also get failed processes that has not been successful. And you can have workflows. I will see if I can demonstrate that as well. And I'm mostly using the CLI when I'm using this, and so that would provide the same kind of information as you can do even more with the CLI. And so looking at one of this function here, we can see we have the target of this is a container executor. As I said, a container executor can either it's a family of executors that can run on edge, HPC and cloud, and can use Docker, Podman, Kubernetes, and Slurm. And this is very simple. The command we want to run is just echo hello world, and we want to use a Docker image called Ubuntu 2004. And this has to be completed in 55 seconds. So we can use my edge server, if you call it that. So I will just, here I can have a list of, I can just whitelist the executor I want to have. If I don't have that, if I don't specify an executor names here, then it will just load balance between executors. So if I want to submit this, I will just type something like this. And then we can also see that there's something happening here. Probably we can do it again. Yeah, you can see hello world coming up here. You can look here as well in the user interface. here you can see this is the kind of the timeline of this execution. So basically, this is a kind of logistic system for computation. So it keeps track of the process, how it's progressing, and who is doing what, and what has been going wrong, and so on. So it has a lot of information about this, what's actually going around, happening, and you can also get the logs here. Hello world. So if I want to run this on a supercomputer instead, the only thing I would have to do would be to change this to Leonardo Booster. Here we go. So this is a supercomputer, and they have a queue. So that means that this can take potentially a long time before it starts. And that's even more important to have this kind of logistic to keep track of stuff. So we might have to wait for this to run. So what I'm using this for is mainly to train a neural network. And that's what I'm using, this HPC system. But then what you can do then is you can integrate this with a cloud platform, so it's seamlessly integrated. Well, that's kind of nice. Now, as you can see, this can take time before it actually starts. So let's talk about running. No, it was completed. No, running. Oh, we can talk about the file system meanwhile. We're waiting for this to start. So the file system, here it's possible to store files, but it doesn't really store files. It actually stores meta information about files. So, for example, this file main.py. Here we can see hello world. Now we get them hello world from the supercomputer in Italy. That's kind of nice. So this file main.py, it is actually stored on S3 on this server, and this is all the coordinates that is required to synchronize this file to an executor. So that's how it's used. So it's a synchronization protocol that uses this method. You can to synchronize file from the meta file system, and it also has a revision system, a versioning system, which is very important. So you can think about this meta file system as Git for data. You can check out files from it, and you can check in files. And so the other thing I wanted to show you was this application, the satellite. And I will reload this. Maybe I will see if I can make this another. Let's rearrange the screen a little bit. No? Okay, can I make another one? Here we go. So Roshinante. This was the demo I mentioned. So here I can select an executor that I want to use. I want to use my edge server, and I want to use the system model. Some of the models I want to use. Maybe this one. And then I would just be able to drag any kind of satellite image to this. For example, this one. And if we now see if we can get the dashboard back. If you look at the processes, no, it was actually successful here. Let's start another one. Let's take this one. And then we can see there's actually a process starting up when I'm dragging images. let's take another one, this one. Now there will be 2 processes running. Or the other one was almost completed, so we have to, let's take another one. Yeah, so if I click here, then now this was completed as well. But here I can get the logs. It's just doing inference on my edge server, basically. But the interesting part here is if you look at the file system, so colonies fs label ls. So here we can check out, we can watch all the file system, and when I'm dragging an image, it's actually uploading to the meta file system. So, and then the generated image is actually stored here, and then I'm storing the model, the source code to the inference. Inference is stored here, and then I have the pre-trained model. When I train a model, it's ending up here. So if you look here in the models, fs ls label. This is actually the weights you see here in the bullet list here. It's so this list of model is coming from here. So if I want to train another, network here, I can Euro HPC demo models, and then QNet CFS. So this is the pollinator tool that I just mentioned it, and I'm using that to, we can call a model maybe webinar, something like that. And I don't know how many epochs, 10 epochs. So if I want to train a new network on a supercomputer, I can just use this. Sorry, we will just use Leonardo for doing that. And this is designed to be super simple to use. I will just, if I want to train this, I will just type pollinator run -- follow, and then there will be a new process here running on Leonardo that will start training a new network. So I also have the data set uploaded to Colony file system. So it takes care of everything, synchronizing all the data across this continuum of platforms. And this will take some time to complete, but when it's completed, then there will be a new model, and it will be something called webinar unit, something in this list. So now it's actually running on Leonardo, and I can click here. It's starting training this model now on the supercomputer. So this become quite powerful. Now you have this. You're starting to see how this meta operating system can be used. So it's quite useful to be able to abstract away all these differences between these platforms, and creating application that you are seeing that can utilize many of the different platforms in a coherent, in a cohesive way. That will be my last the last thing I would say. So it's about ColonyOS is about creating this control layer that makes this possible. So I think I'm running out of time. So
Thanks a lot, Johan. We have some 22 people online. Anyone that has any comments, questions? I guess that you can raise a hand, or you can put it in the chat. As you may see, it's I would at least from my perspective, this is a fairly mature technology that is useful still for experts, but it's constituting one of these parts of the edge to cloud compute continuum that we are looking into. And this is why we wanted to present this MetaOS work to you other guys.
So if there is no question, then I can also make another demo. We can just quit this and then. So this what this actually does is creating a workflow that spans many platforms.
We have two questions here now.
Okay, excellent.
Rafael is asking, can you give some insights on the crypto use?
On the
crypto use.
Oh, right. So as I said, I was using a lot. I was working with blockchains, and what I did was see if I can get back to the slides here. Jump. Here. So in Ethereum, there is something called ecliptic curve digital signature algorithm called ECDSA. It's used basically in all crypto. So, but I'm not using a blockchain, but I'm just reusing that part of that code. And the idea is that every component, an executor and a colony and a user and a colony server has an identity that is derived from a private key. And so this crypto protocol is quite nice because you can derive the identity from a signature. So by signing all the RPC mechanism, you can derive who that is coming from. And a colony server, it keeps track of who every executor and user that belongs to a colony. So that's how it works. So it uses this crypto to implement as kind of a zero trust security mechanism where you basically have to verify every interaction. So that's how it works basically. So a colony server is basically a certificate authority in a sense. So it's a trust anchor. So this is built into the very core of this technology.
Mm-hmm. We have another question from Giovanni. How accessible is it at the moment? Documentation, SDK examples? And I think you touched upon that a little bit earlier.
Yes, it is quite easy to use. There is this landing page, and then you can just click on here. You can get to the GitHub, but there's also documentation here how to. For example, it's quite easy to set up. There is a Docker Compose file, and you can just set up a colony server quite easily. It's a little bit more tricky to deploy this on Kubernetes, but there are Helm charts for that. And then there are documentation how to use the CLI and how to implement an executor in Python, for example. So it's if you want to try it out and you have questions, just contact me and I can help you out using it. So I would be very happy if more people can use this, and that's kind of my ambition to grow a community around this.
There is also a question about the open source license, but which license have you assigned this to so far?
It's an MIT license. So the main repository is this colonies, and it has a MIT license. So currently, that might change in the future, maybe if you're going to integrate with Eclipse. But currently, it's an MIT license.
Yeah. I don't see any more questions. Anyone else that has questions, comments to this? So please use the Q&A. Here is yet another one from Giovanni. Can you outline the main idea of the integration with Arrowhead? Is the idea to support more embedded systems as executors?
Yeah, would you like to say something about that, Erik, maybe?
Yeah, since I'm kind of the Arrowhead guy here, we realized that we can create a service interfaces to Colony rather simple, and that means that Colony can be accessible from any service within an Arrowhead solution, Arrowhead local cloud, Arrowhead network, and that means that we can integrate both the functional orchestration, which is very much on the edge part, where you want to create functions between various components, functionalities between various components, various IoTs, various groups of systems, and so on. And then to when we are moving data to more computational things from this edge thing, this can be moved directly into the Colony machinery, just using a service integration and a functional service orchestration. And then you want machinery, the Colony machinery can actually distribute the computation to the available resources that will be dedicated to a specific or will be assigned for the desired computation. And this is, for example, something that is now planned in another EU project together with this company, Rock Sigma, and a couple of other companies also being suppliers to this mining company, LKAB. Giovanni says, thank you both. And I don't know, do we have a final one or two questions before we have the 10 o'clock timeline? Seemingly not. But then I think that we say thanks a lot to Johan for this presentation. I know it's recorded, and that this one will be, if I understand things correctly, Katarina, this one will be available on the Open Continuum website or in due course. So thanks a lot for joining, and I hope it was of use for you that attended. Thanks. Bye-bye.
Yeah, bye-bye.